My experience in Subhati University was so good. I've enjoyed a lot. I've done so much fun here and I've learned a lot from here.
The experience in Subhati University has been incredibly amazing for me, and hence I would say that Subhati is the best.
It's like a small island or in a city, and you should totally come here if you are pursuing anything.
The experience of Subhati has been always wonderful. यहाँ रहना, यहाँ पे लोगों से बातें करना, टीचर से थोड़ा थोड़ा एक्सपीरियंस लेना और उनकी कभी कभी डांट सुनना.
Jai Hind to all London community of Swami Vivekanand Subhati University. Really, it is a great day for us because we are just going to conduct a online guest lecture of Dr. Sumit Kumar Yadav, Assistant Professor of Operation Management and Decision Science, Department of Management Study, IIT, Roorkee, Uttarakhand. Really, today's guest lecture title is Testing of Hypotheses in Research and Statistical. Really, it is a wonderful topic, and I thank you, Dr. Sumit Kumar Yadav. You have just received our invitation, and you have just given your concern of that day for this online guest lecture. Really, everybody knows that the knowledge creation and research are critical in growing and sustaining a large and vibrant economy, uplifting society, and continuously inspiring a nation to achieve even greater height. Indeed, some of most prosperous civilizations such as India, Mesopotamia, Egypt, and Greece, to the modern era such as United States, Germany, Israel, Korea, and Japan. We are a strong knowledge society that attained intellectual and material wealth in large part through celebrate and fundamental contribution in new knowledge in retail of science as well as art, languages, cultures that enhance and uplift not only their own civilization but other around the globe. Really, wisdom is a knowledge rightly applied. Conducting research in all about gaining wisdom can be exciting part of a college student's education journey, be a simple research paper and thesis, we can say dissertation. If we talk about the research, because research is the art and humanities along with the innovation in science and social sciences are therefore extremely important for the progress and enlightened nature of a nation. Really, we are conducting the two type of research, primary and secondary research, and everybody knows that we are not going for this thing today. But first of all, we conducting the research in hard work, and it always takes time. It requires discipline, focus, effective time management strategies. Research is an activity that leads us to finding a new fact, information, assisting us, verifying the available knowledge, and making us questions things that are difficult to understand as per existing data. Really, it is a more significantly, it is about how researchers systematically design a study to ensure valid and reliable results, address to research aim and objectives. Really, there are so many things because if we're going through this research and how can we just make a research in significantly finding, then for example, how did the researcher go about deciding what data to collect and what data to ignore, who to collect it from, and research in this called sampling design. How to collect it? This is called the data collection method, and how to analyze it. But the problem is that because the data is very important part in research and data collection methods are important because how information collected is used and what explanation can generate are determined by the methodology and analytical approach applied by a researcher. Really, it is because we can say the research can be time consuming and sometimes tedious task. How can make it easier? How do deal with situations such as I have been in research for sometimes now, but I spend a lot of time to get the article and I won. Data collection is an important part of research in order to collect the requisite data for any theme of research. Because but the problem is that after data collection, what particular type of data information which lends itself a particular type of analysis and interpretation of drawing meaningful conclusion and generalization. For this, we need to familiarize ourselves with the nature, merits, and limitation of various research tool. In this lecture, we are just characterize the data type of the research tools and how can we just analyze and how can we testing our hypothesis. such as we are just using the so many things in the field of research is concerned with the collecting, analyzing, interpretation, and presenting of data. And in the field of research, statistics is important for the following reason. The first is that statistics allow the research to design the studies such that the finding from the study can be explored to a larger population. And the second thing is that statistical allows researchers to perform hypothesis tests to determine if some claim about the new drugs, products, new manufacturing methods, and so many more. The reason third is that statistical allows the researcher to create the confidence interval of capture and the uncertainty around the population estimated. In rest of our guest speaker, Dr. Sumit Kumar Yadav, Assistant Professor, Operational Management and Decision Science, Department of Managed Study, IIT Roorkee, Uttarakhand, will elaborate all the aspects about the testing of hypothesis in research and statistical line. Before this, I hand over my platform to our young and dynamic Dean, Faculty of Education, Professor Sandeep Kumar, for brief introduction of our Honorable Vice Chancellor, Professor G.K. Thaplial, Vice Chancellor, SBSU Meerut. As under his dynamic leadership, we are organizing this such wonderful guest lecture in our online and hybrid mode in our campus. Really, thank you, sir, and welcome you all. And I welcome Honorable Vice Chancellor, sir. I welcome our Dean, Professor Sandeep Kumar, sir, and all the participation, those who are just listening through online mode and hybrid mode in our seminar hall of Faculty of Education. Really, I welcome all you participate. Thank you. And once again, I just call the Professor Sandeep Kumar for just inviting our honorable or dynamic Honorable Vice Chancellor, Professor G.K. Thaplial. Sir, please.
Jai Hind and good afternoon to one and all. As Professor Anuj has rightly said, that research as a day-to-day activity, and we can say that the Faculty of Education is continuously conducting many e-lectures and offline lectures, and this is a hybrid mode. The participant from online mode as well as the participant offline mode is also attending this program. And before this topic, the Faculty of Education is continuously conducting the activities related to research like FTP, orientation programs. And before that, we have conducted the lecture on how to prepare the research proposal and how to collect the data and how analyze the data. And in continuation this, today we are conducting the lecture on testing the hypothesis. Testing the hypothesis means when we have collected the data, we analyze, then we are going towards the findings. We are going to conclude our research in a way, we can say the testing of hypothesis. Today in this platform, I heartily welcome our Honorable Vice Chancellor, Major General Dr. G.K. Thaplial, sir, who is a great personality from the field of dentistry, who is the ex-army person and who is the devotee for the day-to-day new challenges, to take up the challenges. And in research, we can say if we are taking the challenges, then we can find something new. Similarly, I heartily welcome the Dr. Sumit Kumar Yadav, who is the eminent speaker, today's speaker from IIT Roorkee. I heartily welcome. And at last, I welcome all the participants, all the delegates who joined us on online platform as well as the offline program. Thank you. Sir, I would like to request our Honorable Vice Chancellor, sir, Professor G.K. Thaplial, sir, for his blessings. Thank you.
Thank you, Dr. Sandeep. Jai Hind, one and all, and good afternoon. A very good afternoon to you all. At the outset, on behalf of Swami Vivekananda Subharati University, I extend a warm welcome to our guest speaker, Dr. Sumit Kumar Yadav, who is the Assistant Professor Operations Management and Decision Sciences, Department of Management Studies, IIT Roorkee, Uttarakhand. I welcome and thank you, Dr. Sumit Kumar Yadav. Hello.
It's working. Fine.
Hello.
Yes, sir, it's working.
Is it
Yes,
okay?
sir. Yes, sir. Yes, sir, you are audible.
In between, the picture is actually missing and some audio disruptions. Is it okay now? Okay.
Yes, sir, it's fine.
So, and I also welcome all the participants who are joining this webinar in the virtual as well as the physical mode. The topic is a really excellent topic they have chosen, and for this I congratulate and thank the organizing team under the dynamic leadership of our Dean, Faculty of Education, and the Professor and Head of the Department of Education, and of course the person who is been instrumental in organizing this, Dr. Sirohi. I thank you all for having called such a wonderful, such a brilliant research person to discuss on this wonderful topic. I'm very much sure that this topic is going to benefit us all, because when we call about research, for that first you need to have an analytical mind. You have to have a critical thinking, and then you have to have some kind of a hypothesis where you are working, in which area you want to work. If you work in that hypothesis and you collect data, but if you don't know how to analyze those data, how to arrive the conclusion, and how to publish the data, that research has no value. Unless it goes to the society, it is published, the research will not have any value. To understand how to carry out the research in a very scientific manner, how to publish the data how to analyze the data in a scientific manner, and how to publish the article, this area is a very interesting and not understood by many. So this needs a clear-cut understanding, and I'm sure that today Dr. Sumit Kumar Yadav will discuss and deliberate upon all these areas, and most of the doubts which our participants have will be cleared by him. So once again, I welcome Dr. Sumit Kumar Yadav and thank you very much for joining us. And I hope in future also we will continue to join. You will guide our student whenever the requirement comes. Thank you very much. Once again, Jai Hind.
Thank you, sir. Thanks for your blessings. Now we are going to move towards today's lecture, and before that, I would like to invite Professor Dr. Rahul Sirohi, the Associate Professor in Department of Education and today's moderator of the event, to come and brief us about today's eminent speaker before starting the lecture. Thank you.
थैंक यू सर। सबसे पहले मैं वेलकम करता हूं आज के जो हमारे गेस्ट स्पीकर हैं डॉक्टर सुमित यादव। अगर हम इनका सीवी देखें तो बड़ा इम्प्रेसिव है और पढ़ने में बड़ा समय लगेगा। ही इज एन असिस्टेंट प्रोफेसर in Management Study, IIT Roorkee. He completed BTech from IIT Bombay and he completed PhD in Management from IIM Ahmedabad. He is a keen learner. He has mastery in research as well as statistics. His article or paper published in international journal. He has been invited speaker in international conference held in European as well as Asian countries like Italy, Spain, Japan, Thailand, France, Malaysia. He has been also champions in sports, swimming and marathon and got NCC B certificate. अब मैं ज़्यादा टाइम ना लेते हुए अपने जो गेस्ट स्पीकर है टुडे डॉक्टर सुमित यादव को इनवाइट करता हूँ. थैंक यू वेरी मच सर.
Good afternoon, everyone. Am I audible?
Yes sir.
Okay. I just want to confirm: is the screen? So I've shared a screen. Is that visible?
Yes sir.
Okay. Thank you, Dr. Sirul. So good afternoon, everyone. Jai Hind. I would like to extend my thanks to Major General Dr. Thapria for inviting me, and also Dr. Sirohi and the organizing team. They have, it's an honor to be invited to a university such as Subharti University. I was going through the departments and other works of the university. It's really impressive, I'm sure. So I also saw one video of the CEO where CEO said that the university is facing locational disadvantage because it's not close to, it's not in New Delhi or Bombay. Let me be very frank, even IIT Roorkee has that disadvantage. But I'm sure with metro coming in and Meerut now being very much a part of NCR, the university will grow and will reach greater heights in near future. So I was also impressed by the initial talk of the organizing team. It sort of came as a help to my talk because they discussed many things in detail about confidence interval and then data analysis. So thank you for that. Now let me get started with the talk. The title that I have been given is Testing of Hypothesis in Research and Statistical Eye. And as the Honorable Vice Chancellor also said that what is very important is for research is critical thinking and analytical mindset. So in general, having that is an advantage even beyond the scope of your professional life. You will start to analyze things in a much better way, and it will be very difficult for anyone to mislead you. So you may, maybe a political leader announces that in my term, the average salary has increased. Now, a lay person would sort of begin appreciating the work of whoever that political person is, and then say that, well, the person has done enormous amount of work so that the average salary has increased. But then there could be another side of it which says that the median salary has decreased. And both of these things can be true at the same time. So it's very difficult. It's very important not to get misled by these statements, and then have a critical mindset and also always be open to new insights that can come after doing analysis of data. So let me get started. So now first, so the title is Testing of Hypothesis in Research and Statistical Eye. Maybe I'll introduce a bit of statistics in the beginning of the talk, followed by I will try to make hypothesis testing as simple as possible, because I understand it's post lunchtime, maybe not a very appropriate time to talk deep mathematics. So I will try to make it as interesting and as easy to understand as possible. So so let's get started. So now, what is statistics? So statistics, it has been defined at several places. So the first definition comes from the very important book, which is also a standard textbook in many engineering colleges for their introductory statistics program. They say it's art of learning from data. Right? So data is what it is. Now, data could be that, let's say you have the average income of all the individuals of our country in 2016, and you also have the average income of all the individuals of our country in 2022, let's say. So this is what our data is. Now we need to be analyzing this data. So we need to have some understanding of how to analyze data. So now if you go to the Wikipedia page of statistics, it says that statistics is a branch of mathematics working with data collection, organization, analysis, interpretation, and presentation. And there's a famous mathematician, Fisher. So he said that statistics may be regarded as the study of populations. Now, what population is, it's a slightly technical term. Will not be having time to get into details of it, but it has to do something with sampling, etc. So, and also it says it may be regarded as the study of variation. So why do we need tools to do any sort of analysis? Because the data has inherent variation. If let's say every data is exactly the same, there's nothing much to analyze, right? And also the third one is interesting: study of methods of reduction of the data. Now, what is reduction of the data? So for reduction of the data, we may need data. So if I, let's say, hand over to you, this is the income of the first person, this much. This is the income of the second person, this much. And let's say I collect the data from 10 crore people of the country. This is the income of the last person, 10th crore person of the country. And these are their incomes. So this is what your data is. Now, how do we analyze this? It's not a very straightforward. Thing, because I mean, the perfect analysis would be you memorize all of them, look at all of them. But then that definitely is not what we can do, because you cannot be going through each of these data points one by one, right? If you estimate, so let's say even if you spend 1 second on every data point, if you estimate, it might the time 10 crore seconds might translate to years. Right? So what is the solution? The solution is we will try to describe this entire data. This is our data. We will try to describe this entire data by a single number or by maybe a few numbers, which are easy to interpret, to which you can associate meaning easily, right? Now, what could be one of these? One of them could be mean or average. And this could be one. Okay? And this, as was also said in the introductory talks by the organizing team, your data, your statistics also you can classify as descriptive statistics and inferential statistics. So initial part of the talk would be dedicated to descriptive statistics, where what you have is you have the data and you are only trying to describe the data. There are several techniques. First is you observe some small set of numbers associated with the data. This could be mean or average, or maybe the highest point in the data, the lowest point in the data. Then you may look at variance in the data. Okay? And then there are some such numbers. So these numbers, again, they have been classified into two sets. One is measures of central tendency, which try to tell you what is going on in the middle of the data, right? So they could be mean, median, and mode. And we all know what median is. Median is the central point of the data. Mean is the average of all the observations, and so on. Now, you could also have measures of dispersion, which try to measure how spread the data is. So they are in some sense a measure of inequality or spread of the data. So now they can be characterized by quantities like range and covariance. Range and variance. Now, what is range? Range is typically the highest point minus lowest point, and variance is a function of. So if you allow me to use some formulae, variance is nothing but this: summation I equal to 1 to n xi minus mu whole square upon n. So this will be your variance. It is some sort of compilation of you take every data point and then you subtract it from the mean. And why do we do the square? Because we do not want that if one observation is lower than the average, another is higher than the average, we don't want that to get cancelled, right? So in order to avoid that, we take square. Right? So the way these formulae have come, there is a reason why they have come. They did not appear. God did not give us these formulae that use this as a measure of dispersion. We have deliberated on several things, and which led us to finally. These are now the more accepted ones for a data set, right? So average, variance, median, and these things. Now, here is a link to two. So now data you can also describe by your pictures. So what do you mean by pictures? So you may, so let's say your data is x and y. So you may have a scatter plot like sort of a thing. So you have x and then you have y, and then let's say these are your data points. Right? So I mean this may be one representation of the data. So I hope all of us would appreciate that this sort of representation is still better than you being asked to look at those numbers, right? All right, and you have several tools and techniques which can help you easily draw these kind of pictures, and maybe even simple softwares which are widely popular like Excel and so on. They can also sort of help you with this. So let's say this is our data for profit, and you want to see how profit is associated. So maybe you can select this and then go to insert recommended charts, and let me see if that chart is there. Okay, and you can draw this sort of a chart, right? So now you have, I give you two alternatives. You look at these 50 numbers, and the second one is you look at this chart. So what does this chart tell you? This chart tells you that, well, this is sort of the minimum value, this is the maximum value. So actually this is box and whisker plot. If there are outliers, they are treated differently. So we'll not get into details of this. I'll just tell you the name. It is box and whisker plot. Okay. Now, what you can notice that you have a box, and at the lower point of the box, what you see, this point corresponds to the 25th percentile. Now, what is the meaning of 25th percentile? This means that 25% of the observations are below this data point, right? And what is the interpretation of higher point of the box? That it is the 75th percentile. What do I mean by that? That 75% of the observations have a value lower than that particular point. And you see a line also going in the box. So this line is corresponding to the median. That this is the central point. So 50% values are below this, 50% values are above this, and then you have a cross which tells you about the average and so on. Right? So data you can represent by a box plot, and I would recommend you to maybe watch these two videos by Hans Rowling. They are I mean approximately 18 to 20 minutes each, and a very good demonstration of how you can do maybe storytelling with data. Okay? Simply using descriptive statistics. All right. So now once we have done this, let me. So there are a few more terminologies which are cross-sectional data, time series data, and why do we need to get into these terminologies? Because for so let me just tell you, just give an example. So let's say what you have is from the year 2003, 2004, 2005, and so on up till let's say 2021. You have the GDP data of India, and you have the GDP data of let's say China. You have the GDP data of France, and let's consider only these three cases. So now this entire data, so if you look at, let's say, only the GDP of India for all these years, we say that we are looking at a time series data. Now, if instead you look at, let's say, the GDP of all these three countries in the year 2005, then we will say that we are having a look at the cross-sectional data. And you look at this entire, all the data points in one go, we will say that it's a panel data, right? So, why do we need these terminologies? Because for these different classifications, you have different tools and techniques which can help you do the analysis. All right, so this is about your just a second. So now let me jump to, so we have sort of seen what is statistical. So statistical thinking is something that we should try to do, right? So which means that if any numbers are being told to us, we should have a careful look at, okay, what does this mean? So even in the context of, let's say, COVID vaccine, people were saying that this has 97% efficacy rate, this has 95% efficacy rate. So we need to ask these questions. Okay, what does that 95% mean? Just because it is large, should we come to a conclusion that it's a good number or not? So this is the sort of mindset we should aim to develop. Right? Critical thinking in spirit. Okay. So now to introduce hypothesis testing and to make it interesting, we would need to So first of all, we would need to take some examples. And secondly, we need some basic introduction to what probability is, what a random variable is, and what are some of the random variables. So I will be doing that in the next 10 minutes. Just let me, okay, in the next 10 minutes or so, I'll very briefly give an overview of what is probability and so on. So what is probability? If you actually do the maths, etc., it may look cumbersome, but in philosophical sense, it is very, very interesting. It is nothing more than simply, so let's say you have, it originates from the concept of experiment. So now what you have is an experiment, and we may like to conceptualize anything going around us as experiment. So for instance, let's say India and Pakistan are playing a match, right? So this is the experiment. Now what would be the sample space? Sample space would be what could be the possible outcomes of this experiment. So the possible outcomes could be that, okay, India wins the match. Right? This is one possible outcome. The next possible outcome could be Pakistan wins the match. And the last could be it is a draw. Right? And now coming back, so what was the experiment over here? The experiment over here was a match between India and Pakistan. Now you have sample space. This is the sample space, and then you have these 3 points in the sample space. So what probability is nothing more than to each sample point you just associate a number, and that number has to follow some rules, right? We follow many rules in our life. We drive to the left, and then we stop at red light. So like that, this probabilities have to follow a rule. So the rule that this follows is, so let's say this has a probability 0.4, this has a probability 0.35. So the rule that essentially it should follow is that the total of all these should be equal to 1. Right? This is the only law that it should follow, and all of them have to be positive. So probability in the spirit is nothing more than this. Now we associate an understanding with this number in the sense that if, let's say, India and Pakistan play in these similar circumstances, we would sort of say that, okay, if they play 1,000 matches, then under similar circumstances, India would win 400 of them. Pakistan would win 350 of them, and 250 of them might end up in a draw. Right? So now you may think that, well, why do you associate such a large probability with a draw? So maybe you consider a test match, right? We are all used to seeing T20s, and we all had a recent heartbreak where India lost, unfortunately. So, all right. So this is our probability, and for the purpose of this talk, we don't need more than this. Right? Now let's come to a random variable. So what is a random variable? A random variable, because what we would be doing is in hypothesis testing, we would be requiring these notions. So I am bringing this up at this moment. Now a random variable is you have a sample space. So this is a sample space, and then to this sample space you map one real number to it. Now this real number has no restrictions. It could be a positive, it could be negative, it could be 0 or anything, right? So let's say that a random variable could be, so let's say if India wins, I throw a party to my friends, right? So then my spending would be let's say 1,000 on that party. And if Pakistan wins, no party, 0. And if, because I'm mourning, I'm crying, and I don't have the energy to go out to a party. If it's a draw, then all of us go out, but I don't pay for everyone. So maybe I spend 250 rupees. So this is my expenditure, and this we are calling as random variable. Now, what is random variable? So let's say we have always been doing these sort of problems that, okay, x plus 4 is equal to 10. And then we say that, okay, this implies x is equal to 6. Right? So now this is also a variable. So what's the difference between this variable and the variable that we just mentioned? The difference is that while the value of this x you can determine, the value of this random variable you cannot determine before the experiment. You only observe the value of the random variable. That's a small catch. Right? So the value of a random variable, we observe it after the experiment has been performed. Although we can have several possible values that this random variable can take, and we can have the corresponding probabilities. So, for instance, for this problem, we see that the random variable can take the value 1000 with probability 0.4. The random variable can take the probability can take the value 0 with probability 0.35. It can take the value 250 with probability 0.25. Right? So we have these three numbers, and these are your these are the values of the random variable. So now one may ask that, all right, if this is the case, can I get an idea about what would be the average spending of this entire sort of scheme? So now for that average setting, so let me just write. So you have x, let me call x as a random variable, and we realize that with 1000, it takes the value 1000 with what probability? 0.4, and it takes the value 0 with probability 0.35, and it takes the value 250 with probability 0.25. Right? So you see that all of them have to add up to 1, which is indeed happening. Now, how do you associate the meaning of average over here? Because in descriptive statistics, we said that we have the data with us, and then we are associating the meaning of average. Right? Over here, you cannot say that it's 1000 plus 0 plus 250. So what we do is, so you might have seen this sort of a formula, summation xi probability x equal to xi. Right? So the basis of this formula is nothing more than that, okay, if you have a similar setup and you do this many times, what would be your average spending? So let's say if in this setup, India and Pakistan play 1000 matches. So we can expect that approximately 400 times India would win, where you would have to spend 1000 rupees, and you can expect that 350 times Pakistan would win, where you would have to spend nothing, and in 250 times it may be a draw, where you would have to spend 250 rupees. Just a second. Okay. All right. So 250 times it's a draw, where you have to spend 250 rupees. So now you have, if you want to get an idea of the average spending, what is it that we'll do? We will say that, okay, I'll divide by 1000. Right? Now this formula will give you exactly the same thing. Right? So this in the context of random variable is nothing but the expectation. All right. So random variable also, it's in terms of concept, it's not very difficult. It's just that you have a bunch of values and the probabilities associated with it. So if you know all these things, we will say that we know the distribution of the random variable. So this is the distribution of x. So this is nothing but distribution of the random variable x. Okay. Now let's proceed, and you have now there are several things which may be discussed, but for in the limited time that I have, I will have to wrap up by 3:30. So I'll maybe discuss only one of them, which is a normal random variable. So what is a normal random variable? A normal random variable is nothing but you have this sort of a graph. Now what does this graph represent? So if let's say this is mu, and why this normal random variable becomes so important, that will also become clear in a while, right? Why? So if you remember, it has there is some probability density function. So on the y-axis you have the probability density. It's not probability, mind you, it's probability density, and on the x-axis it is the values that the random variable can take. So how do you find a probability? So let's say if this value is, for instance, 10, and you want to find out the probability that this random variable will take the value between 15 to 20. So we can do one thing. We can just look at this particular values 15 and 20, and we just find out the area of under this graph. And the total area under this graph must be 1. So whatever is that area, that is the probability that the random variable will take a value between 15 to 20. Although this function is quite complex, I mean complex in the sense that the expression for this normal random variable is something like fx is equal to 1 by square root 2 pi sigma, and then e raised to minus x minus mu by. So we don't something like this. Now we don't need to actually get into details of this, but it's important to appreciate that it has this density. Right? So it's a random variable which can take these values. And how do we find out the probability? We just take the area under the graph. So I mean, these days we have a lot of softwares available to us, which we don't actually need to do the integration and so on. We have a lot of software which can directly give you these values. So understanding the concept is more important. So now, all right. So this is about a normal random variable, and because of this normal random variable, you have, I mean, this becomes important because of this theorem, which is central limit theorem. Now, what is central limit theorem? Quite a simple concept, but very wide applications. So it just says that if you have many random variables, let's say x1, x2, so don't read the theorem as it is. It might lead to some confusion because it has some terminology which I have not introduced before, sample size sampling. So just ignore this. But we'll keep this in mind. So let's say you have x1, x2, x3 up till xn. Let's say these are your random variables, and all of them are independent, which means they have nothing to do with each other. And although it has a more technical meaning of independence, but for sake of simplicity, we'll assume that assume the interpretation that they have nothing to do with each other. Okay? So, and what else needs to happen? So let's say you are looking at this particular random variable, the average of all these, and they are independent and they are identically distributed. What do you mean? What do I mean to say when I say that they are identically distributed? That the probability that, with which, let's say, x1 takes a value will be the same as the probability with which x3 takes that particular. So in terms of distribution, they will be same. So now if you are looking at the distribution of this x bar, if you allow me to call this x bar, and for all these x1, let's say the mean is mu and the variance is sigma squared. Right? So if you do this, you will notice that the distribution of this random variable is approximately normal, with mean as mu and variance as sigma squared by n. Right? So usually this is for large n, and the thumb rule is that n is greater than or equal to 30. So why this? So now I hope you realize that why normal distribution is such important. Your x1, x2, x3 might be coming from any distribution. Right? It doesn't matter. You don't even need to know the distribution. You just need the mean and variance, and you can tell the distribution of the summation of these. Okay, so moving ahead, or maybe I'll just these discussions I'll just maybe come back later if time is left, because hypothesis testing I realize might take more time. Okay, so if there is time left, I'll come to these distributions also. You have many distributions that are coming out of normal distribution. So okay, all right. So hypothesis testing. Now, what is hypothesis testing? For hypothesis testing is a technique which allows you to make statistical decision using observed or experimental data, right? So I mean, for it may also be treated as some sort of a conflict resolution tool, right? So now, let's say I want to get an answer to this question. As a researcher, I want to get an answer to this question. Do students perform better if tests are given in the morning? Right? And we can go on and debate that, okay, students indeed perform better, students do not perform better. No, in the morning students are fresh. And then somebody might argue that no, if tests are given in the evening, then students have time to perform in the morning and afternoon, so they do better. And there is no end to argumentation, right? People can keep on arguing, but the only effective way to actually try to see if this is true or not is by taking some data and then doing some analysis on it, right? So now what hypothesis testing will do is it will give you a tool to do that analysis. So let us say you actually can go and collect that data that you so let's say Subharti University, you take a department, and what you do is you divide it into groups of so let's say you have 101 students in the class. So for 50 students, I take the test in the morning. For 51 students, I take the test in the evening, right? So let me consider scenario 1, where you have this 1, 2, 3 up till 50, and the tests are happening in the morning. And for these 51, 1, 2, 3 up till 51, the tests are happening in the evening. So this is the evening group, and the first is the morning. So now let's say I take the test, and there are several things which I need to keep into mind. What are those things? The way I divide this 50 and 51 should not be such that naturally the students giving the test in the morning are anyways expected to get higher. So let's say if I'm taking a maths test, I should not be keeping the students interested in mathematics in the morning slot and students not interested in mathematics in the evening slot. That would sort of anyways and that would not give you correct inferences. It would sort of lead to bias that, okay, students who are interested in mathematics, you can expect them to get higher score in mathematics. So if you put all of them in the morning, then it's a problem. So then how should we put this 50 and 51? Purely randomly. Okay? So you take out of those 101, randomly you pick any 50 and you put it in the morning, and for 51 you randomly do the same. Okay. Now how do we proceed? So now we say that you have this 50 and you have this 51, and in scenario 1, so let me call this morning. So let's say the score of morning. So what score should I look at? You have 50 different scores, right? I hope even for this simple problem, it's not very clear how to proceed with the analysis. So for instance, I look at the score of the students in the morning slot. Now, and let's say they happen to get, so you will have 50 different numbers. So what can we do? We can maybe try to summarize all these 50 numbers. And how do we do that? Let's say I do the summary and I make it equal to, I find out the average. So this is some sort of average, and you get it to be 49. And you also get from the evening, you get it to be maybe 48, right? So from these two, can you conclude that students perform better if the tests are given in the morning? Maybe not, right? So why maybe not? Because the difference is not significant, right? But if, let's say, this is scenario for scenario 1, let's say you had another case where you have the students in the morning, they are getting maybe 58, and students in the evening are getting maybe 38. So then this makes it a more stronger case to do what? To conclusively tell that, well, students in the if tests are given in the morning, students perform better. And for the first case, you may still believe that, okay, there is some scope of allowing it to happen by a random sort of a situation, right? It may just so have happened that the morning students happen to be slightly better off, or it was just a matter of that particular day. Maybe if you take the test again, you may see the reverse result, right? Whereas if for the second scenario, we don't tend to say those kind of things because the difference is sort of huge. So now how do we exactly measure whether this one is large, or maybe if it's 48, 49, we are not convinced. If it's 48, 52, are we convinced? So how to draw that line? How to close that debate one and for all? So now what can be done? So before I proceed with this example, I will do this example. I have one such example in this Excel file. So I will actually be demonstrating that very soon. But before I actually do that, let me get into. So what is hypothesis over here? Do students perform tests better if tests are given in the morning? So let's say you are the one who is trying to prove that, well, the students actually perform better if tests are given in the morning. So then what would be the hypothesis? The hypothesis would be, just a second. Okay. The hypothesis would be that students indeed perform better in plain English. So now there are certain terms in hypothesis testing which I will introduce. So that will help us in doing the discussion better. All right. So you have null hypothesis, What is null hypothesis? The null hypothesis is usually it is the status quo. Usually it is a status quo, or it is the reverse of alternative hypothesis. So what do I mean? So maybe people right now do not believe that it doesn't matter if tests are given in the morning or afternoon. Let's say that is a popular belief. So that would be the null hypothesis. Or to put it otherwise, the claim that is coming in. So you are wanting to prove that students perform better if tests are given in the morning. So you take the onus of proving it, right? So then that goes into alternative hypothesis. And this is usually denoted by H0, and this is denoted by HA or H1. So I'll be using HA for convenience. Now, how do you perform hypothesis testing? Before you have the data, there is nothing you can do, right? You do not have the data. The only thing that you can do is do a subjective argumentation, in which I am not saying is not a good thing to do. You should have, discussions, etc. should definitely happen. But if you want to make use of this technique, hypothesis testing, we need to have data, right? So what you do is you have these two conflicting opinions, null hypothesis and alternative hypothesis. We perform, we collect the data, right? We collect this data, and what do you do after collecting the data? We do some analysis of this data. To conclude whether null hypothesis is acceptable or whether alternative hypothesis is acceptable. So we decide whether to reject the null hypothesis or not to reject the null hypothesis, right? And how do we do that? From the value of a statistic T. Now, why do I call it statistic T? So for our score example, so let me just maybe write it over here. So maybe this is the morning people and this is the evening people, right? And the scores that these morning people got, let's say, are M1, M2, up till we said 50 people over here, and the scores that these people got are E1, E2, up till E51. Fine. So now what shall we do? We can look at the average of these. Maybe I'll call it M bar. You look at the average of these. We will call that as E bar. Right? Just introduce some notation. M bar is nothing but M1 plus M2 plus M50 upon 50. E bar is E1 plus E2 plus E51 upon 51. So what do we do now? We may look at the difference between M bar and E bar, right? Because M bar minus E bar, so we have this broad idea that, okay, if M bar minus E bar, if it's high, only then you can conclusively say that, okay, this is, it indeed is the case that morning students are performing better. Otherwise, it will be difficult to say that whether morning students are performing better or evening students are performing better, right? So, okay. All right. Now, so I see people writing on chat. So if you have any questions also, you may post on chat and I'll take it up. So now you have T equal to M bar minus E bar. So what we do is we understand or we view this as one possible outcome of an experiment, right? Now, what do I mean by experiment? So maybe so there is also some sort of randomness over here, right? So maybe these morning people happen to be, although we selected it randomly, it may have happened that these morning people are happen to be the lot who is more interested in statistics or in mathematics, right? So they might actually perform better. So what we do is we say that, okay, you have this T equal to M bar minus E bar, right? Now we would say that if this T happens to be greater, now greater is again a subjective thing, right? So let me give you two scenarios where what I'll do is, this is the number of students who gave the test in morning. So let's say in morning the number was 500 and in evening the number was 600. Another scenario. And over here what you observe that the morning average was 48 and the evening average was 45. So this is case number 1. And let me take the case number 2, which is the one that I have specified in greater detail. So let's say case number 2 is morning was 50 and evening was 51. Okay. So and over here also, let's say you observe the same things. M bar is 48, E bar is 45. Right. So I hope it's clear to everyone that for case 1, you will be more convinced that the students who give tests in the morning tend to perform better, right? Versus case number 2, where it's not very clear. Although it's the same scenario in both of them, but because you have greater number of students over here, our belief is in some sense more, right? So how do we resolve these sort of issues? So whether this 500 is correct, or whether we stop at 500, 600 or 100, 200, that is still something that is a question at this point in time, right? We have not resolved that yet. So let me come back to how do we do hypothesis testing. We collect the data, and then after collecting the data, we look at the value of a statistic T. What is this value of a statistic T? So the value of the statistic T in our example is, so we have decided that it will be the difference of these numbers, m bar minus e bar, right? And there is nothing stopping you from taking any other statistic. Maybe you can look at m bar upon e bar. That would be another way of conducting this hypothesis test. And you should say that, okay, if m bar by e bar is greater than significantly greater than 1, then I will say that, okay. So I just use the term significant. So what does that mean? Now you have m bar minus e bar. The problem with m bar minus e bar is the distribution associated with that would be very, very difficult to find. But fortunately for m bar minus e bar, we can do some things. Because what is it that we are saying? We are saying that t bar is equal to m bar minus e bar. Now what is m bar? M bar is nothing but m1 plus m2 up till m50 upon 50. And e bar is what? E1 plus E2 up till E51 upon 50. Now, what can we do? So before doing the experiment, we can say that this m1 plus m2 plus m50 upon 50, whatever distribution, let's say this m1, m2 is coming from, we just saw a very important theorem, which is central limit theorem. And central limit theorem will help you that say, well, all right, this approximately follows a normal distribution with certain mean. So let's say mu1 and with certain variance, maybe sigma 1 square. And this, the other one also follows a certain mean, let's say mu2 and another variance mu2 square. Okay. So now the results are that the results are that if you do this normal distribution computations, this final thing would follow a normal distribution with mu1 minus mu2 and variance is sigma 1 square by, or maybe I should write sigma 1 square by 50, sigma 2 square by 51. That is what central limit theorem said, right? 50 by 50. Sigma 1 square by and sigma 2 square by 50. Now, what is mu1, mu2? We don't really know. Okay, so now is the time to actually formulate these hypotheses. So what is this hypothesis? So just let me, so for this context, what would be the hypothesis? You have said that, what is it that you have said? You have said that if tests are given in the morning, students perform better. So you want to prove this, mu1 is greater than mu2, right? And this we say that, so this is something that we are talking about a larger group, whereas we are testing it only by taking data of these 101 students and we are wanting to make a general statement, right? So we will say that this m bar will not be able to exactly capture mu1. This is some sort of indicator of mu1. Right? This is, for instance, let's say you want to find out the average height of all the Indians. What do? We can't go to, we can't go on and measure the height of every Indian and then take the average, right? That's not feasible. So what is it that we do? Let's say we observe the height of some 1 lakh Indians and then we say that, okay, well, their average is a good estimate of the average of the entire country. And that's essentially what your, the difference between census and survey. So survey, it does not consider everyone. It considers only a subset of the population. And from that subset, we are making inferences about the entire population, right? So this is what is inferential statistics. So in hypothesis testing also, we will say that, well, if you have the entire data, there is nothing to test, right? If you have the entire data, you simply observe which average is more. Is the average of morning or is the average of evening more? We do not have this entire data. And maybe it's not possible to get the entire data, because the kind of statement that you are trying to make is very dicey. You are trying to say that the students perform better if tests are given in the morning, right? So it's a very sort of wide statement that we are wanting to make. So we just view the data that we have collected as a sample data coming from a very large population. Now your null hypothesis would be the opposite of this. So it will be mu1 less than equal to mu2. And whenever we do the testing assuming the null hypothesis at the borderline, because that makes it easier to test, and also that makes it harder for the alternative hypothesis to get accepted. So those are some technical issues which you may ponder over later on, or okay. So we will do the hypothesis testing assuming this mu1 equal to mu2. So what happens if we assume this? This becomes 0, right? And then this becomes normal 0 and sigma 1 square by 50 plus sigma 2 square by 50. Do we know sigma 1 square, sigma 2 square? Not at all. But you can estimate this, right? We can estimate this how? From these 50 observations. So you look at their variance and then their variance with n minus 1 in the denominator, and that will be a good indicator of their this sigma 1 square, or at least we hope that it will be a good indicator of the sigma 1 square, right? Okay, what next? The next thing is, because we have now appreciated the distribution of t bar, so how do we proceed? We have so what is the distribution of t bar that we have computed? It's normal 0, sigma 1 square by 50 plus sigma 2 square by 51, right? So if you draw the density of this, you would observe that it is something like this, 0 and then some variance, so maybe something like this. So this is okay. So let me say it again. So this is normal mu1 minus mu2, right? And why? What gave me the authority to put it equal to 0? Because we do the testing of hypothesis assuming that the null hypothesis is true. We assume this is true. So this is very interesting. We assume this is true, and then we try to see that if it's actually true or not. So what do I mean by that? Just to give an analogy, let us say I give you a coin, right? I give you a coin, and I ask you to, and I say that it's a fair coin, right? You say no, it's biased towards heads. I say, well, why don't you toss it? So you toss it, let's say 1,000 times. So you toss a coin. So let me just write it. So let's say you toss a coin 1,000 times. And what do you get? Maybe you get 895 heads, right? And 105 tails. So now can I say that this cannot happen if the coin is unbiased? What do I mean by unbiased coin? That the probability of heads is equal to 0.5 and probability of tails is 0.5. Okay. So for an unbiased coin, is it theoretically impossible for this to happen? No, right? So if let's say this is case 1, and maybe in case 2 you observe something like this, 510 heads and 490 tails. So I hope all of us would agree that case 2 will sort of lead you to a conclusion that no, the coin is okay. But case 1 will lead you to a conclusion that no, it's not a fair coin. The coin is giving more heads than it should, right? Or maybe the probability of heads for the coin is definitely more than 0.5, right? It cannot happen, whereas it can happen. So how are we differentiating? We are differentiating on the basis of probability. So we are saying that, so now comes a very important argument in hypothesis testing, that so now for this coin, if you are saying that the coin is biased towards heads, so what is it that you are saying? You are saying that probability of heads is greater than 0.5, right? This is the alternative hypothesis. This is what you are saying. And what is it that I am saying? That no. Probability of heads is equal to 0.5. I am saying no, it's not a biased coin. The chances that it will be heads is equal to 0.5. So now we will, as I said, we will do the hypothesis testing, assuming the null hypothesis to be true, right? So what do we say? We say that this is your probability of heads. So the argument is like this. It's, I mean, if you allow me to put it in Hindi, we can say that ठीक है, मैंने मान लिया कि आपकी बात सही है, that you have, so let's say we are considering case A. So now listen to the argument. So case A, I will say that मान लिया आपकी बात ठीक है, which बात, that probability of heads is 0.5, right? लेकिन अगर आपकी बात ठीक होती तो ऐसा नहीं होता. It's some sort of that sort of argument. लेकिन अगर आपकी बात सही होती तो ऐसा नहीं होता कि 895 हेड्स आ जाते, और इसीलिए मैं अब ये आपकी बात नहीं मान पाऊंगा. So now by this argument we will be rejecting that the probability of heads is 0.5 in case 1, whereas in case 2 you say that I believe that what you are saying is correct, which is what you are saying. Who is you over here? You is the null hypothesis. So now we will say that I believe what you are saying is correct, and the data shows that what you are saying can happen, right? There is a good chance that it may happen. So I will not be able to say no to what you are saying, right? I will not be able to conclusively say that this is not correct. Okay, so now a similar thing happens in your this sort of a setup, where we have assumed a distribution of t bar, and we say that this is normal 0, sigma 1 square plus by 50 plus sigma 2 square by 51, and let's say this comes out as some normal 0 and some values. So now maybe this point you call it as 10, and maybe this is minus 10. So this is your normal distribution graph. Now what happens is, let's say you observe this value as maybe somewhere over here, which is 1, right? Let's say this happens to be 1, this t bar happens to be 1. So what would we say? We would say that, well, this is a likely value. This is very much a likely value if our null hypothesis is correct, right? No problem with that. But if you observe, so if it's a likely value, then there is no reason to reject the null hypothesis. Agreed? So case number 2, where let's say the value that you observe is actually this 20. So we notice that no, this is not a very likely value. This value, the chances that a random variable coming out of this distribution taking this value is very small, right? So we will say that because the chances is small, we will reject the null hypothesis. And how do we measure this small? Now that small measurement is also dependent on the sort of decision that you are trying to make, right? Although we would still be aware of the fact, we will be wary of the fact that the null hypothesis could be incorrect, and I mean could be correct, and you still reject the null hypothesis if you notice something as strange as 20. And the other sort of thing can also happen, that the null hypothesis is actually incorrect, and you have actually ended up rejecting, accepting the null hypothesis, right? So both these things can happen. So what we do is we take a small chance. And how do we measure that chance? So let's say I'm measuring that chance by 5%. So this is known as level of significance. So what I'll say that, okay, I will, so I'll assume that the null hypothesis is true, and I will allow only a 5% chance that the null hypothesis is rejected, even though the null hypothesis is true. So what I will do for 20, I will compute this particular area, the area to the right of 20. And if this area happens to be more than 5%, then I will reject the null hypothesis. If this area does not happen to be more than 5%, then I will, no, if this area happens to be less than 5%, then I will reject the null hypothesis, because then it looks like an extreme value, right? For one, what do you observe? For one, the value that you observe, you see that it's close to 0.5, right? It's almost half of the graph. So for 1, we will not be able to reject the null hypothesis. Whereas for 20, we'll be easily able to reject the null hypothesis. All right. So this is the sort of central argument in hypothesis testing. And then we characterize these errors by, all right, that you have these 4 possibilities that your null hypothesis is actually true, and you end up rejecting the null hypothesis. So this is not a happy situation, right? So we say that if this happens, we have committed a type 1 error. What about this? This is a happy situation. Null hypothesis is true, and you did not reject the null hypothesis. This one, null is false, and you rejected the null hypothesis. This also is a happy situation. And in this 4th one also, we'll say that we have committed a type 2 error. And we would typically want the probability of type 1 error and probability of type 2 error both to be low. But now they are sort of competing things. If you place more faith on null hypothesis, we would have larger chances of rejecting the null hypothesis, and so on. So I mean, if you place more faith on null hypothesis, then we will have lesser chances of rejecting the null hypothesis. So more chances of not rejecting the null hypothesis, even though the null hypothesis is false, right? So this is the problem with the this is the competition that is sort of going on between type 1 and type 2. So the only way to reduce both of them is to collect more data. You cannot reduce the chances of both type 1 and type 2 errors simultaneously. The only way to do that is you collect more data. So you don't take the test of 15 students, you take the test of the entire university. Maybe 5,000 students, 5,100 students, right? That is the only way. And several more things have to be ensured, that it's actually random and then whatnot. The students are sort of similar in background. You don't want to be giving a computer science test to students from dental surgery department, right? So all these things controlled for, we can make these sort of inferences. So now, and there are some more examples that are there in this file. So so we won't be having time to do all of that, but maybe this p-value is interesting. So what I will do is I will just briefly discuss this p-value, and we'll see the application of this p-value using one example, and that is where we'll close the session. So now, what is p-value? P-value, so in hypothesis testing context, it appears a lot, is the probability of obtaining a result as extreme as the one that was actually observed, right? Under the assumption that the null hypothesis is true. So under the assumption that the null hypothesis is true, if you look at this particular example, this graph itself is under the assumption that null hypothesis is true. I hope all of us would agree to that, right? That is why you have a 0 over here. We were able to say mu1 minus mu2 equal to 0 because we assume that the null hypothesis is true. All right. So now, if you say that, then what happens? Then we said that you have observed a value 20. Right? So which are the values that are more extreme than 20? 21, 22, 23, and so on. Right? And similarly for 1, which are the values that are more extreme than 1? 2, 3, 4, 5, and so on. Now, how am I defining extreme? So extreme values are which are in some sense away or in the direction of alternative hypothesis. So your null hypothesis wants mu1 to be equal to mu2. Now this is more away from that particular thing, right? So the p-value would be the area of this green region and the area of this entire orange region. Orange region would extend beyond also, right? So then let's say this green region happens to have an area 0.001. And this orange area happens to have an area of 0.45. So this is the p-value for green area, and this is the p-value for the orange area. So p-value for orange area and then p-value for the green. Now the thing is, how do we reject the null hypothesis or accept the null hypothesis? We will say that if the p-value is low, then it's an extreme value, and if it's an extreme value, we will reject the null hypothesis. Extreme value has the same interpretation as you had over here. So this 895 hex is an extreme value, even though it's theoretically possible that this would happen, but still it's an extreme value. So we would say that no, I will find it difficult to believe this, so I'll reject the null hypothesis. Right? So so p-value. So we may remember this, that if the p-value is low, the null hypothesis should go. Right? So if the p-value is low, the null hypothesis should be rejected. Okay. Now. These are the steps in hypothesis testing. We will formulate the problem by clearly writing null hypothesis and alternative hypothesis, and there are several theses. So there are several books which are. So I may want to recommend the one by Jagya Kelly. The title of the book is Business Statistics. So that has a very good discussion on how to clearly write the null hypothesis and alternative hypothesis. So first we do this, and then you decide on this level alpha of the test. Usually it is 5%. So what we will do is we will compute the p-value. If the p-value is less than 5%, reject the null hypothesis. If the p-value is more than 5%, we will say that we cannot reject the null hypothesis, right? So now the next thing that we do is we decide on the test statistic t. So in our example, it was a difference in the average. It depends on the different examples. And then we find the p-value of the test statistic, and then we give a verdict by comparing p-value with the level of the test. Okay. So we will see some applications now in Excel, and then and that would be it. So let's see the applications of hypothesis testing. So first of all, let me simply say this example itself. So let us say you have these two just a second. Okay. You have, let's say, these 4 instructors, and you are trying to see whether there is any difference in the instructor. So this is ANOVA. Let me come to it a bit later. For now, let me maybe just copy this data to, okay. All right, let me copy it over here, and then let's say we are trying to do the test for this. Okay. So we are trying to see, or maybe just for the sake of discussion, let me not deviate too much from what we are doing. So let's say this is the score that students got after the morning test, and these are the scores that the students got in the evening test. I'll bring that instructor example in a while. And you want to test whether people actually do perform better if tests are given in the morning. So what you can do, you can say this morning test, this is the evening test. So you may want to look at the average. So the average would be average of the morning test. And this is the average of the morning test, and the average of the evening test would be, this is the average of the evening test. Okay. So over here it's reverse, but so let me just reverse this. And let's say this is morning. Okay. Now can we conclude that students perform better if tests happen in the, just let me check. Okay, this is all right. This is also all right. Okay. So now can we conclude if students perform better if tests are given in the morning or not? Why is it changing? There is some random component, I guess, in some cell. Okay, no problem. I'll take care of that. Okay, now it's not. So now, how do we conclude? So what you do is, I mean, in Excel, you can do these things. And so you just go to data analysis, and then there would be a test for 2 samples for means. So I just select this, and then variable 1 range. So this is the variable 1 range, and you have variable 2 range. And what is the hypothesized mean difference? It is 0. And I'll make some selections, and then let me view the results here only. Okay. No, so then it's what Z test 2 sample for means. Just allow me 1 second. So this is the variable 1, and then this is variable 2. So this is exactly the similar setup that we were doing. Just that morning ones have 49 people, and more that has 0, and then labels. And let me now just select this. Okay. So this it is asking. So just let me write any random number, or you assume equal variances. And say okay. I mean, there are several assumptions which might go into it, which is why it's not working properly. The assumptions are whether you want equal variance, then you would have to estimate it differently, and so on. So because the objective is this illustration, let me just go a bit fast. And okay. So now what is it that you see? We see that it has reported everything, mean, variance, and you notice the p-value. So what is the p-value? 0.02. So this is the p-value, pt less than equal to t. So now is this less than 5%? Yes. So what we will say that yes, we will be able to reject the null hypothesis, which means that students in morning actually perform better than if tests are given in the morning, students actually perform better, right? So this is one hypothesis testing example. Now, if you might have seen ANOVA also. So this is one example of ANOVA. Now in ANOVA, what is the test about? So remember, if you simply ask Excel to do it, it will do it for you. So you just have to select this, go to data analysis, click on ANOVA, and then click on OK, and then it just says input range. So you just give this as the input range, and you press OK, and you press OK. You will get some numbers. Now, how do you interpret these numbers? That is a different issue. So So in ANOVA, what is the null hypothesis? The null hypothesis is all of them are same. So this may be thought of as, let's say a company is producing tires, and what you have is 8 samples of tire from company 1, and the numbers are the radius of the tire. From company B, you have these 6 tires. From company C, you have these 7 tires. From company D, this is the radius. From company E, these are the radius. And you want to test the hypothesis that whether all of the companies are same or is there a difference. So we will frame this hypothesis where the alternative hypothesis would be at least one of them is different, and the null hypothesis would be all of them are same. So if you do ANOVA test, eventually what happens is you get this, right? You get this. So now in this, you notice that you have a p-value. So now, and this p-value we notice in several places, in hypothesis testing, in ANOVA. So in ANOVA, this p-value, so remember, whenever we get p-value, it is corresponding to some hypothesis test. We might not explicitly be getting into what is the test statistic over there and so on. But in ANOVA, the test statistic is designed such that it starts following an F distribution. We have not discussed F distribution, but forget about it for the moment. Just look at this p-value. So this is a p-value for that hypothesis test. So what is it? 2.04 into 10 to the power minus 7. So what does this tell us? That we would be able to reject the null hypothesis, which means we would be able to say that at least one of them is different. Okay? Now one more example, the final one for regression. So let's say this is the data of 50 US startups, and we are trying to see you have the R&D spent in dollars, the money spent in administration, the money spent in marketing, and this is the profit of those firms. So we are trying to observe that can we try to predict whether profit, can we try to predict profit from marketing spend of a company, administrative spend of a company, and R&D spend of a company, right? So we make a model, and the model, if you simply make, you see that regression, and then input Y range would be this, and then you have input X range. So let me just input X range, and you have labels. I'll say it as 0, and then let me just show the results. So now you have, so I just copy this, and you notice even in this you have several values. And how do you interpret this? So you notice that you have so this model, actually, if you have seen regression, you may know that from here you can build the model like that. Profit is equal to this 50,000 plus 0.8 times R&D spent minus 0.02 into administrative spend plus 0.027 into the marketing spend. Right? This is how you can write the profit, or the expected profit, to be more precise. So expected profit would be 50122.19 plus 0.8 into R&D spend. So which means that if you spend 1 more rupee in R&D, your profit will go up by 0.8 rupees on an average, plus minus 0.02 into administration plus 0.02 into marketing. Now the catch here is you may give any numbers to regression model and it will give you some numbers. But now, are these numbers actually important? Is the model actually worthwhile to consider for describing the phenomena that you are doing? So for that, again, several hypothesis tests can be conducted, and you notice that this is, so over here, let's say the model was expected profit is equal to some alpha plus beta 1 times R&D spend plus beta 2 times administrative spend plus beta 3 times marketing spend. So what does this value consider? This is the p-value of some hypothesis test, which we are not getting into details of it, but it tries to measure, first of all, whether this entire modeling exercise is worthwhile to consider or not. So for this test, the null hypothesis is beta 1 equal to beta 2 equal to beta 3 equal to 0, and the alternative hypothesis would be at least one of them is non-zero. So what does the p-value tell us? The p-value is very, very small. So it tells us that, well, you may consider trying to describe the situation by regression, right? Because this is very small, so at least one of them is non-zero. Right? So what about these 3 p-values? So this is the p-value for beta 1 equal to 0 was a null hypothesis, and the alternative hypothesis was beta 1 not equal to 0. So what does this tell you? Again, the p-value is very low. which tells you that this coefficient can be taken seriously, 0.8. What about the p-value for administration? You see it's very large, right? 0.6. And for this, the null hypothesis would be beta 2 equal to 0. The alternative hypothesis would be beta 2 not equal to 0. So what does this 0.6 tell you? That it's very large, which means even though you have got some number, it was not able to pass through this hypothesis test. Okay? Because if the p-value is not low, you will not be able to reject the null hypothesis, which means the coefficient of administration is not significant. Right? You cannot be giving two solid, or at least in the presence of R&D and marketing spend, you cannot say much about this administration. So what I wanted to highlight is that even in regression, you have this hypothesis coming in. Right? You have this, so you have a p-value, which means it is corresponding to some hypothesis test. All right, so this is all I had to share. Thank you so much for listening. I hope I was able to add some value. Thank you so much.
ओके, थैंक यू सर। आपका बड़ा अच्छा रहा है, ये जो सेशन है। आपने हमें रिसर्च के बारे में बारीकी बताई और कैसे स्टैटिस्टिक्स का यूज करते हैं, वो बड़ा अच्छा लगा। सभी जो हमारे पार्टिसिपेट हैं उनका भी जो रिव्यू देख रहे हैं तो उनको भी काफ़ी अच्छा लगा। ये उनका जो कुछ प्रॉब्लम थी स्टैटिस्टिक्स के बारे में, उनको भी काफ़ी मदद मिलेगी इस सेशन में। थैंक यू वेरी मच। अब मैं सबसे पहले I thanks to Vice Chancellor, our university, Professor Dr. G.K. Thapiyal. He gave his valuable time. He is a great personality. He always guide and promote the faculty of the university to conduct research program, seminar, workshop, and guest lecture. I also thank to our Dean, Professor Dr. Kumar. He is also great personality in his guidance. Faculty of Education is constantly touching highest in field of education. I always thanks to our HOD, Professor Dr. Anurag. He is also learned personality. He keeps guiding us to do something in new department. And last, I also thanks to Dr. Sumit Kumar Yadav. He gave his valuable time. He knew, अगर देखें, हम अपने रिव्यू को देखते हैं पार्टिसिपेंट के, तो वो बता रहा है हमें, his lecture is full of knowledge and remove many doubts for statistics and use of test and simply use of statistics in research. I also thanks again Dr. Sumit Kumar Yadav. Thank you very much, sir.